Yo, and welcome to Shooting the Soil, where we shoot the soil with a microscope, with a camera through the microscope, and share with you our microscopy experience. And we're all about regenerative soil. My name is Matt. I have a certification in regenerative soil from Matt Powers, and I'm a home gardening enthusiast. Today, we are looking at, by popular request, Oly Mountain Fish Compost. Heard a lot of good things about this compost, so decided to get a bag and share what we see under the microscope. So we are at 400x now. We're at 100x, excuse me. And we are just scanning through. We see a lot of little bits, but I'm seeing a little bit of fungi in there. Looks like we got an amoeba here. Let me see if I can get a better focus on that. Yeah, nice looking amoeba. That's always a good sign to see in your compost. Good facultative biology there. And yeah, seeing some small pieces of fungi so far. And we're seeing some big chunks of organic matter and stuff like that. Seeing very few, mineral pieces like this. That's always a good sign. Some composts these days can have quite a bit of sand in them. Some of the popular box composts, which rock dust is good for promoting the biology and making a good compost, but not when it's a heavy percentage of sand, let's say. We'll take a look at this tube as it settles. Actually, the tube's looking still very dark and rich for a compost, but I'll bring that up under the webcam here in just a moment. It's a good test that you can do, basically just a salinity test to see what falls to the bottom, what gets suspended in the middle, and then the organic matter tends to float to the top. And yeah, very busy part of the slide here. Hoping to see that little... Nope. Not seeing anything big moving yet, but a whole lot of organic matter. Probably might be a part of an insect there. Could be plant matter, but it's all about getting the organic matter levels up in our compost. Do see something small moving around right down here. When we go into 40x, we'll be able to see a lot more life just as far as the bacteria, but trying to make out if that's a ciliate or maybe a nematode. Do want to give this compost the benefit of the doubt. It's winter here, so when it showed up, it was totally frozen, but it thawed out in the basement, and it's pretty warm in there. So, about 65 degrees now, so it thawed right out and it's been thawed out. So that could decrease our large, sightings of nematodes and whatnot since it's frozen. But other than that, I've experimented with sticking some stuff in the freezer, just as far as shipping samples go, to see if there was much difference. And there really isn't much. It's the main thing I noticed that was different was slight decrease in nematodes and ciliates. And we're just switching over to 400x now. Let me get dialed in. Now we'll be able to see the bacteria and whatnot. And holy cow, that's a lot of little wiggling bacteria in there. Definitely no lack of bacterial life in this compost. It's very rich with that whole bunch in there. Yeah, and this is at a 1 to 10 dilution, so we put 10 drops of water and 1 milliliter of, 10 milliliters of water and 1 milliliter of compost. Trying to see what's moving that all around down there. It's small. See if I can get a focus. Might just be bacteria. Or there's probably a little protozoa, a little flagellate in there flying around, but some bacillus are pretty mobile. They'll have a single cilia and can actually be pretty mobile. Well, most of them, like here, you just see them wiggling around. Pill shapes, bacillus type of bacteria, where there's thousands of types, more than we even know. And then the round ones are cocci, and occasionally we'll see a little spiral, which is a spirilla. But here we have a small little organism that could be an amoeba. Also could just be somebody in a cyst. Since it was frozen, I'm surprised we'll see more round little cysts where they hibernate and wait for the conditions to become right. And they'll pop out of the cyst, go to town, start cycling their nutrients and doing the thing. And we see a fungal spore, actually two fungal spores. And we'll get them in the middle so you can see. Yep, always nice. See some fungal spores. We want our compost to be complete and diverse. Help create that nice balance. Yeah, and we see mostly all organic matter. So the organic matter clumps like this, that nice brown glomalin. That looks like it might have been a piece of a plant or a leaf. All getting broken down. The bacteria are going to town on this, reducing it quick, making it plant available. Yeah, and just look at all that, carbon-based life. Adding that carbon energy into the soil. Driving the whole system. All right, we'll scan a little bit more. Kind of a weird shape, but I think that's just a little piece of a mineral. In and about all this organic matter. And we got a fungal strand, it looks like there. I think I can make out a septi right there, separation in this fungal hyphae. Yep. All right, let's scan around a little bit more. Feel free to ask any questions in the chat. And Happy New Year to everybody, by the way. It's 2025. And yeah, here we go. That looks like, I think that's a cysted organism. It's not perfectly round, but probably going to see a couple more of those. Yeah, definitely plenty of life to wake right back up once it's not going to hurt it too much by being frozen on the shipping truck. Yeah, I see a nice little hyphae there. It's kind of with the light glowing a little bit green. But if we go back and forth, and like right there, see the light refraction went away. So sometimes with the microscope, colors can be tricky. Now it looks very clear, but then we get some light refracting, and now it looks green. So one day we're going to upgrade our scope so we can get better looks and some top-down lighting so we can see what color that actually is. And let's see here. This is a fish compost. Can't get a good focus on it, but that might be a diatom or a piece of a diatom, but they kind of look like little crystal structures in the soil. See a lot of them in marine environments, but yeah, definitely a whole lot of bacteria. We got some more motion around there, but I think it's just bacteria and or flagellates bumbling around down there. Yeah, and here's some examples of nice septi in a fungal hyphae. Let's see how long this strand is. Yeah, pretty long. Yeah, good example. Fungal hyphae. Yeah, I do. I know the scope that I want to get from LW Scientific, the I4 Lumen. And I think you can only get it on their website directly through them. Occasionally, I've seen some of their older scopes pop up on, like, say, Amazon, or, you know, maybe I might be able to find a deal here and there. But it's definitely a pricey scope. But can't complain with this $350. Who makes this scope again? Oh, I'm drawing a blank. It's not AM scope. It's the other one that you can find on. Doesn't even say anywhere on it. Can't believe I forgot the name. I think too much about getting the LW Scientific that I don't even remember what this one is. It'll come to me in a second. Too many names of biology in my head. Yeah, got another little round looking fungal spore there. But for just doing bright field, the scope works out pretty good. Whoa. We got some cool, lot of motion. Looking inside this amoeba. Perfect example of a testate amoeba, and there's a whole lot of motion going on inside there. Yep. Swarming with microbes. Could be on the outside of them, swarming all over, but they will. This over here is the mouth of the testate amoeba, and they'll open up and things will swim right in and back out again, and the amoeba will still be okay with it. Saw a great video, actually Matt Powers shared, of a nematode going right in to a amoeba's mouth. That was really cool. All right. Yeah, no, another fungal spore here, another fungal spore there. And loads of bacteria everywhere. Yep. Got a football-shaped fungal spore. You see those everywhere. Haven't seen any larger organisms yet, Doug. But I wouldn't be surprised if we found a nematode or a ciliate. Largest we found is the amoebas. Oh, another amoeba over here. Another testate amoeba. But as far as fast-moving organisms, we're only we've only pretty much gone up and down once on this slide, because we kind of got distracted by some stuff and went into 400x, but could jump back out here in a second and do a 100x scan, see if we can find anything big. But another amoeba, another fungal spore. This one might even be sprouting, starting to extend and grow. But there are some that are just dormant in that shape as well. It's quite a lot of different fungal spores, and they all look pretty similar. Slight differences here and there. Alright, I think we'll, let me adjust my settings here so I don't blind you guys first. And probably about something like that, and we'll switch back over to 100 and see if we can find anything big down there. But yeah, with it being frozen, that's one thing I always notice, is less ciliates and nematodes. Less big stuff moving fast. But all that bacteria is definitely woken right up. Well, let's see what we can find. Is that something there? Nope. Alright, where are we on the slide? I think if we go over a little bit and now up. It's about where we left off on the scan. Anybody see anything big moving? Oh, let's see. Does it say the brand on here? I just got this off Amazon. Nope, just says cover glass, made in China. There's probably better ones, but these ones work fine. Pretty easy to clean. Not super fragile, but they still break with the slightest bit of twisting. But I haven't broke one with a microscope yet by running the objective into it, so they're pretty tough. See a little bit of motion down there, but I think it's just all that bacteria moving little microaggregates around. Yeah, stuff is a lot of small motion. But and a lot of amoebas. It's always a good sign. Good healthy compost. Let's see. Oh yeah, how's that? Wow, yeah. Slide's still I mean the tube is still really dark. I was hoping it might clear up a little bit. But here. Yeah, still very rich. Let's see. Yeah, it's hard to see with the light, but there's just, yeah. It's not much sand or anything like that settling at the bottom. Let's let that settle a little bit more, see if it clears up so we can see through it a little bit better. But that's good, turbidity test. And it's definitely a lot of plant available nutrients for that being that dark. And let's see, where were we? I think we were still going up. Always the toughest thing to remember what direction you were just going on the slide when you get distracted. A little bit more focus. Big chunks of organic matter. And that moving? Nope. Let's see. And there's the top of the slide. So we'll go over and back down again. It's tough. Sometimes if there's a ciliate in there, you can totally miss them because they swam across and now they're back over to where I just scanned. One technique is you can actually just leave the slide on there, and as it dries, you can come back a little bit later before it's fully dry, and usually all the big microorganisms will kind of get squished right into the middle. But so does everything else, so you don't get a very good look at them because they're piled up on everything. But sometimes when you don't see any, give it a little bit, let all that squish, and then you can at least count a few and know they're in there. See some motion, but I think it's just all that bacteria. Yeah, big chunks of organic matter. Got another. That could be, it's very golden. Some amoebas can get that color, but that could be a cystic organism. Does look like there's something inside of it. I think that is somebody probably formed that one on the truck on its way over here when things got a little frozen. But as soon as this goes into the soil, they'll wake back up and get to work. All right. Oh, small motion right there in the middle, but hard to make out. I want to do a little bit more scanning before we zoom in again. Let's cruise on down. And towards the bottom. All right, go up over here, and we'll take one more scan up. See what. This would be nice to get top-down lighting. I think it's just a chunk of organic matter, but really hard to see if it could be large enough to be a small worm or some kind of larva. Could grab a nice high-powered flashlight and shine it on it, but did have one of those around, which is kind of fun to experiment with. So there are some ways to do some top-down lighting. They have the little. I haven't had much luck with the little microscope. They're more like for working on computer parts, not quite 400x soil microscopy. So they're not quite bright enough. But if you get one of those super high-powered LED flashlights that are ridiculously bright nowadays, those actually work pretty good. Except I got to manually hold it over the slide, which is kind of a pain in the butt, unless I built some sort of, or got a mic stand for the flashlight. Yep. I think that's another round cyst there. Yep, looks like a good chance all the big microbes are sleeping still. But I think we still might be able to find something. Yep, seeing more amoeba. Definitely no shortage of life in there. Definitely see this compost yielding some nice results. Yep, and that looks like another cyst there. Got some more fungal hyphae. Decent fungal hyphae numbers. Not the best we've looked at, but that's perfectly fine. For a book recommendation, I would definitely say Matt Powers, Regenerative Soil. He's got it all laid out with illustrations, and it's definitely one of the easier reads. Other than that, there's all the teaming with microbes, teaming with fungi. All his books are really good. All right. Just scanning along. Yeah, there is a lot to be learned. We don't know the half of all the functions that these little microbes perform and how they all interrelate in the soil food web. We have a pretty decent idea, but There's a whole lot more to be learned in this space. And just how the plants put down exudates to, promote certain types of microbes. And how we can, work with nature's system to provide the best stuff for our plants when they need it. But, something to be said about the biology, because they've been doing it for a lot longer than we have. It's pretty amazing what they can do. So yeah, we got a whole lot of organic matter here. Is that a big fungal hyphae, or no, probably just plant roots all twisted up in this spot. Hoping to see somebody wiggling around in there. Most of the time you find them near or close to these busy areas. Yeah, definitely. Because of all that stuff there, it made this part of the slide really busy. That's one thing that takes a while to get. Yeah, we already were over here and we looked at that. But just the art of dropping the slide so the water perfectly spreads out, or dropping the cover slip on the slide as it perfectly spreads out, is takes some work, some practice. But this one came out pretty good. Pretty much got 70% of the cover slip covered, and we just got a pocket down over there to the right. Alright, let's see. We might want to go over just a little bit more. Peek down here real quick. Yep, that's what. So all this stuff piled up and didn't squeeze out into that lower corner, and made the slide very busy. But that's what happens. Yeah, it's definitely more fun looking at aquatic systems. The pretty much always find large organisms moving around at high speeds in aquatic systems. It's definitely a different system than the soil. But I was thinking I have a pond, and actually two ponds on the property, and we could check out, because aquatic systems are part of the whole system. What do we got right there in the middle? And, there are overlaps in the science between the two. Yeah, sometimes, like those aquarium habitat people are usually good people to talk to, because they have a lot of experience when it comes to, balancing an ecosystem, and they've been working with biology for a while in those types of systems, and then in that space. Thought that might have been something right there in the middle, but not moving at the moment. Let's see if we can spot anything and get out of this super busy part of the slide here. A lot of cool looking stuff down there. Decent amount of fungal hyphae weaving through all those aggregates and organic matter, forming that sponge. Hey, we got something purple. That's weird looking. Alright, I guess we gotta go check out the weird looking purple thing at 400x. Alright, let's get a little bit more ISO. Let's go there. Oh, more light. Alright. What could this purple thing be? Where was it? Was it over here? Over there? There it is. Ah. It's really weird looking. Alright, we gotta adjust some light a little bit here. brighten that up. Maybe do a little bit of manual lighting. Let a little bit more light through so we can see. Really strange looking. Well, that's a new one for me. Anybody ever seen purple? I'm guessing it's a cyst. Like, look at this perfectly round cell wall in here. But then it's got all this built up around it. And then a bunch of stuff inside. Yeah, just check and make sure you guys see the mouse. That's a really interesting little critter. You know, with all these different shapes and that cell wall, it's definitely not like a piece of microplastic or anything. Usually when you see a weird color or a weird little strand, it can be plastics, but no, I definitely think that is something alive. Yeah, definitely, you know, if you're watching this later, drop a comment if you've ever seen anything like this under the microscope. Actually, I want to snag a quick little video here. That's pretty interesting looking. Alright. Recorded that. Yeah, it's the fun part about microscopy is you never know what you're going to find. We may have found something that nobody's seen before. Or it could be very common. I'm interested to find out. Definitely going to do a little research and see if I can find anything that looks like that. But haven't come across anything looking like that yet. Yeah, you have a nice example of amoeba here. This mouth open. Teeming with that bacteria. Alright, let's see. Where were we on the slide? We're going up out of the busy area. Yep, and we got some other little bubbly looking cysts there. Yep. And with all this stuff, the slide's very deep. You can tell that it's quite a bit of depth. It's hard to get focused on what may be moving that, but definitely impressed with the bacteria numbers. You know, and even if you don't particularly need bacteria, and you already got plenty in your soil, it's still technically, you know, carbon-based life. So you're, in a way, adding more carbon to your soil. They'll be eaten by other organisms, break down, and a couple little fungal hyphae. Yep. More amoeba. Very clear testate amoeba. Yeah, that purple thing, I don't know of any bacteria that is that big. Pretty much the biggest bacteria is maybe like that I know of is like 2 or 3 microns, and pretty much just one of these little circles here would be about 1 micron. So they really don't, you know, some spirilla are quite long, maybe 6, 7, 8 micro, you know, little bacteria in length. It's an interesting shape. Probably something aquatic, like a diatom or something. And we got, that's definitely a flagellate bumbling around. I think that's what a lot of what we're seeing, just moving this stuff around. Small protozoa with one cilia. Yeah. More plant matter reducing there. Let's see. Are we going down or up? I always forget. I know we got a little bit more room over here to scope around. Stay in at 400x. Follow this route down. Oh. More amoeba. Yep, I think we're getting close to a amoeba record on this compost compared to other ones that I've done. I put a couple of other composts that we looked at in the description if you want to check them out and compare. Help get me some more viewing hours. That's the only thing that we're stuck on in order to get monetized. And it's by year, so I put out a lot of videos when I first got started, but then don't put out quite as many videos. And it seems like it's tough to get the viewing hours in a single year up to the monetized point, but we like doing it. And not many other channels that share soil microscopy experience to the extent that we do it here, so we know we don't do it as much. We're gonna stick with it. And maybe someday I'll get monetized. Could be a pollen. There's a lot of weird looking pollens, but it really looked... Pollen are usually pretty spiky, but the only thing that I'm saying that it wouldn't be a pollen is because of that perfect, it looked like a cell wall, that perfectly round thing inside of it. But potentially could be a pollen, because they come in a variety of shapes, colors, and sizes, usually very spiky. And, you know, and that's why they make us sneeze, because they got, you know, something that you wouldn't want to get poked with by the looks of most of them. Yeah, definitely some cool stuff. Got a spore. Is that just a little piece of a... Yep, just looks like a hyphae, just because of these septi here. That's definitely all sorts of little circles that are most likely cysted organisms. What do we got here? Well, it looks like it kind of used to be a nematode. Kind of looks like it's got some internals, but definitely looks dead. Well, tattering on the edges of the cell wall, and I don't see anything left of its head, but that might have been a nematode at one point. Could just be mistaking it for a little piece of plant matter as well. Alright. Yep. Really thick cell wall there. That's definitely a cyst. We got another. More amoebas. Yep. I'm going to call this the amoeba compost instead of the fish compost. Yep, no nematodes yet. But yeah, like I was saying earlier, it did get frozen because it's winter, and frozen on the truck. But it's been about a week and a half fully thawed. But that's from my experimenting with freezing samples and unfreezing them. That's the one major difference, is I see less nematodes less ciliates after freezing. But usually everything else, like fungal numbers, bacteria, pop right back to life. Yeah, it's definitely not a fungal dominant compost. Definitely bacteria dominant, but there's fungi. I wouldn't say it's low in numbers. You know, for a business, you definitely want to get at least this much fungi in there, but the fungi is the process that takes longer. So you really just want to, you know, shave off a little bit of time and getting enough fungal numbers to promote the fungi once it's in the soil, but still make a good quality product that you don't have to wait 6 months before you can ship it. Or even longer, some Johnson Sue, fungal dominant compost, takes up to a year after the thermophilic phase to really get fungal dominant. All right. So let's see. Oh, here's our slide. Drying up. Coming in on us. Yeah, but overall, pretty nice compost. Very low amount of sand. Just enough minerals to promote the biology by what it looks like. Because the bacteria are thriving. I think this compost won for bacteria numbers and amoeba numbers. And we got some fungal spores. Let's take a look at this. Wow, we got some, looks like a plant root. Some interesting stuff going on in there. Breaking things down. Reducing. Alright, well, pretty much scanned around the whole thing. We missed a couple of corners, but other than that, it's been a pretty decent quick look and assessment on the Oly Mountain fish compost. Definitely think my plants are going to like this. I got pretty good fungal numbers, so the fact that this is a little on the low side as far as fungi doesn't bother me. Just kind of want to boost the system, get some more organic matter in there. Kind of an interesting shape. Maybe a bug foot, leg, joint, or something would be my guess. Usually when you find weird little shapes, antenna-like things, just little bug parts that are broken off. Yep, I think we're right up in the corner. Sometimes organisms like to hide right on this edge. Take one little scan over here to the corner. Oh yeah, I think we saw that fungal hyphae. We're doubling back. Oh, here comes the slide drying, but looks like we got a little cluster of fungal spores there. So, yep. Definitely not going to hurt the fungal numbers. A lot of spores. Yep, 3 more right there. Might have some, might be a fungi inside of that plant matter. Or it could just be part of the plant. They have little cell walls that can be misidentified, but I don't know. I'm leaning towards that's a hyphae in there. Or on top of it, reducing it. I did actually look into. I'm just assuming they use some, some fish waste in their compost. So, some with all the plant matter and everything, they just mixed in a little bit of fish. That's what I would assume, but I don't know their exact process. And there are some, some varying processes where, sometimes they prepare the fish first and add it in later and mix it. Other times they just compost it all together. Once it reaches that thermophilic phase, it gets nice and hot, should kill off most of the bad guys. Then you let it sit. The biology rebounds. And you got a product you can market. But then if you're just doing your home compost, you kind of get away with a lot more. Doesn't have to go fully thermophilic. You can wait for, a year or so, get it nice and, fungal dominant, and add in all sorts of good materials. I like going with kelp from the sea. Don't prefer to add much for meat products into my compost, other than maybe some bones here and there. But mainly just because pests, raccoons will get attracted by any meat product and stuff like that, where if I don't add any meat, they don't seem to bother it. But, yeah, and one thing to consider is the stuff that breaks down meat, has a higher percentage of bad guys. And, we don't want to be eaten by that stuff. That's another reason to consider, not using meat in the compost. But, as long as you're safe and, not breathing in or eating the compost, it's not going to cause much of an issue. But, yeah. Well, there's flagellate wiggling around quite a bit. But, yeah, I'm just kind of going around in circles here. Let me see. Do we got any more questions? All right. Yeah, pretty much, plant matter, all, carbon materials, wood chips. It's tough to actually, spot anything, I don't even, most of the time I just look at compost, so I don't even know what broken down fish would look like, because by the time we're scoping it out and it's ready to use, it's pretty much all gone. All reduced. And eaten by the biology. Yeah. Any last questions before we sign off here? Definitely hit those buttons if you would be so kind. Help grow the channel. Another cool football-shaped spore with either something on it or something in the middle there. But yeah, overall I would definitely recommend this compost. Does look good, and from what I've heard from other people, it does. They see a nice plant response, so it's nice to see it from the microscopy level before I judge it on plant response after giving it to the plants. So just gives us, two different ways to look at, one soil health and plant health. And then we can make correlations between the two. It's pretty neat. Anyway, unless anybody has any questions, and if you're watching this later, just drop them in the comments. I'm always happy to help and answer what I can. But yeah, other than that, I think that's a wrap, folks. So yeah, Happy New Year's again. Hope everyone has a great year. And yeah, grows some nice, healthy, delicious food. And until next time, we will catch you on the flip side.